We have a diagram showing giving a velocity time graph, which models the velocity of the car as it approaches and drives through a residential area. So clearly, the velocity is decreasing to this constant amount. And we're given that the velocity between 0 and 5 is actually given by a quadratic, but we don't know p, q, or r. And then afterwards, it's a constant. And it's given that the acceleration of the car is 0 at t is equal to 5. Okay, because that's when it then goes into its constant velocity. So it's actually telling us, as well as it being constant here, it's instantaneously, the gradient is going to be 0 here, which is something we can look at in a minute. And then we're asked to determine the values of P, Q, and R. Well, I'm going to talk about two different methods for doing this. Both of them are going to, first of all, look at this term here. That's my constant term. And that means that R is going to be 18. So when t equals 0, v is just going to be r, which, like I said, is also 18. You know, v is 18, it's also r. They're the same. Okay, let's take a look at these two methods. So now I've got that v is equal, let me write it here actually, v is equal to pt squared plus qt plus 18. I'm going to get that in, get rid of the r. Okay, method one. This is the way the answers did it, and it's a good method, and it's maybe the one you'd think to do. So I thought it's best to go through it first. Method one is to substitute, first of all, the value of t equals 5 in and v equals 9, which is going to give 9 is equal to 25p plus 5q plus 18. Therefore, 25p plus 5q is equal to minus 9 if I just rearrange it. And then we're going to come back to this idea here. Actually, both methods use this concept, but that is going to be the minimum or a stationary point, more importantly. It's going to be when the instantaneous gradient of the curve is equal to 0. So we need to find dv by dt. And that is just going to be, bring the power down to, it's going to be 2pt, lower the power, plus q. And then when t equals 5, this instantaneous gradient, the acceleration, by the way, is equal to 0. So I'm going to get that 10p plus q is equal to 0. And now I've got a pair of simultaneous equations. There's two ways we can deal with this. We can either substitute in q is equal to minus 10p, or we can use the sort of equating coefficients method, and then subtract, in this case, the equation. It feels a little bit easier to do the substitution because this is such a simple equation. So q is minus 10p, sub in to this one. So 25p, and then it's going to be 5 times minus 10p, so minus 50p is equal to minus 9. That's going to give me minus 25p is minus 9. And therefore p is 9 over 25. Slightly awkward coefficient, but that's what it is. I mean, we're modeling a real world situation, so you can't always expect it to just be a nice number. And therefore, q is going to be minus 10 times 9 over 25. Of course, you can use a calculator for this, but I'm going to do it without. I can actually divide this through by 5 to give me 2, and this through by 5. So I'm going to get minus 18 over 5. And therefore, v is equal to 9 over 25 t squared minus 18 over 5 t plus 18. And I'm just going to highlight these answers as well because we were specifically asked for P, Q, and R. Okay, nice. Right, method two. I said there were two methods. Okay, method two is also using the minimum, but it's using, I'm going to use completed square form. So V, oh, hold on. Since 5, 9 is a minimum, or in it, or just even having a vertex, a turning point, then V is actually going to equal P times T minus 5 squared plus 9. Right, how have I gone to this? When you have something in completed square form, let's ignore the P for a moment, then you can always look at it and think, well, this term is always going to be greater or equal to 0, assuming P is positive, which it is here. And the smallest it can therefore be is 0. And that will give me V is equal to 9. You get your maximum when you have it in completed square form. And when does it reach the maximum? When T is 5, because it's when this bracket is 0. So you can go from completed square form to finding the maximum and the minimum. That should be a topic that you've seen before. Um, you can also do the opposite though. So if you have the minimum, you can say, well, it must be in this form because then, that's the only way that I can get my minimum of 5, 9. Now, is there going to be a constant here? I need to have some sort of parameter here because all of these, for different values of p, like 2, 3, 5, they will all have the minimum in the same place. They'll just be stretched by different amounts. Now, why do I know to put p here and not just some other constant? Because I can see when I expand this out, the only way I'm going to get pt squared, because I'm going to be relating these two in a minute, is if I put a p here. So if I'd replaced it by like a general constant k, I would later on show that k is equal to p. You can do that, but I can go straight to here. Do you know what? Just to convince you, or maybe to be, as comprehensive as possible, let me put a k there. And this is going to equal k, and I'm going to expand this double bracket. Don't forget, this is t minus 5 times t minus 5. So I'm going to get some cross multiplying going on. T squared minus 10t plus 25, close bracket, plus 9. And that's going to be k t squared minus 10 kt plus 25k plus 9. And now I'm going to compare with v is equal to p t squared, because they're the same function, that's the point. So k must equal p, because they're true for, they're going to equal one another for every single value of t. You can actually equate the coefficients. I'm not going to go into lots of detail on that because I'm spending quite a long time just even going through two methods, but read into that a bit more if you're not quite happy with that. And therefore, v is going to be p t squared minus 10 pt plus 25k plus 9. So now I can actually, I can compare and say, oh, sorry, put a k there, haven't I? But I've replaced k by p. My fault. So now I can also say that 15p plus 9 must equal 18. Okay, so I have compared the pt squared with the kt squared, and now I'm comparing the constant term 25k plus, sorry, 25, what am I doing? 20, that should be 25. Easy for mistakes to happen. 25p plus 9 must equal 18. And so p, I can minus 9, and I can divide by 25. P is 9 over 25. So you see, I've got the same answer. Of course, I have to get the same answer, just using a slightly different route. I've not needed to differentiate. And I'm nearly there now, because I can then finally compare minus 10p with q. Okay, and actually that's exactly what we got before. And if we solve it, q is going to be minus 10 times 9 over 25. And I'm again going to get minus 18 over 5. So just a different route. I actually did it this way. I kind of was aware I could differentiate, but I just thought completing the square. I don't know, for some reason I thought that's the way they wanted us to do it. But we get the same answer both methods. So that's the main thing. Finally, in this question, we're asked to calculate the distance traveled by the car from t equals 2 to t equals 10. And that is going to be, in fact, the area under the graph between t equals 2 and 10. So this area is very simple to find. It's just the area of a rectangle that has a base of 5 and a height of 9, 45. This one's going to be a little bit tricky to find, but it is in fact going to be the integral from t equals 2 to t equals 5 of our quadratic function that we have. Okay, so I can add 1 to the power, going to integrate this, add 1 to the power, and divide by 3, which is the same as just getting 3 over 25 t cubed. Over here, this is going to become 9 over 5 t squared. I'm doing this quite quickly now, but I'm dividing by raising the power to 2, dividing by the new power, and I'm just cancelling it out straight away. And then plus 18t. This is a mechanics question, but it's still good practice. I don't actually know whether it's how much it's checked in the mark scheme, but you should show some sufficient working to show that you can integrate, because there's a lot you can actually do on your calculator, which I'll show you also in a minute. So I'm going to substitute in for 5, 3 divided by 25. You can take little shortcuts like this, times 5 cubed minus 9 over 5 times 3. Sorry, why did I keep using 3? 5 squared plus 18 times 5. That gives 60. Then we're going to subtract the same, but with 5 replaced by 2. See, I don't advocate doing this stuff without a calculator. Obviously you want to speed, you want to be pacey. 744 over 25. And 60 minus answer. I'm just going to get it as a mixed number, 30 and 6 over 25. Although this is a mechanics question, so let's just write it as 30.24. And therefore, the distance traveled is going to be this 30.24 plus that 45 I had from up here, which is going to be 75.24 meters. So I think that's a good level of working, showing how we got our answer. Just want to show you one way you can check with this class with calculator. There's a little integration function, and it doesn't do indefinite integration, but you can put, it will do this. And then we can, right, it's going to work in terms of x. There's a little x button here. Just replace all your t's by x's. Now, technically, we should put a bracket around both of these when we're integrating to show that we're integrating the whole thing with respect to x. You'll actually get away with it, but I'm trying to show good practice. So I've got that 756.25, which is that or that as a decimal. So you should definitely use that to check because it didn't take long. But I advise showing this working as well.